Hello, everyone, and thank you for joining us at the ATCx AEC conference by Altair. For those who just joined us, my name is Moein Ahmadipour, and I'm product manager for the S-Frame suite within the Altair team. So in this session, I'm going to walk you through modeling and design of a timber structure in S-Timber, and we're going to take advantage of hybrid design capabilities of S-Timber to design some steel beams in the structure as well. Let me introduce the structure that I'm going to work on to you. The structure I'm going to use today is a terrace structure for a warehouse building. It's made of heavy timber columns resting on concrete pedestals. There are glulam beams supporting the main terrace platform. There are concrete pedestals over which the timber columns are standing. And then at the end of the design, we're going to use steel beams to support the main terrace platform as well and see how much it makes a difference in the design. Let's review the dimensions of the structure together as well. The height of the structure is 10.5 meters, including a 0.5 meter concrete pedestal. The cantilever length of the terrace is 7 meters, measured against the wall of the warehouse building. And then the overall width of the terrace structure is 80 meters in 10 meter spacing increments. To reach our design, there are a few steps that we're going to follow today. The first step is to model the geometry of the building, which involves preparation of the grid systems, modeling of the members, and also applying the supports to the structure. Next, we're going to work on the loading of the model, and it involves creating the load cases and combinations for our model, and then applying the loads to the right members. We will then perform analysis on our structure, using which we will run an integrity check on the structure. We will review the results, including the deflections and force diagrams. And in the last step, we're going to do the design, which involves performing a code check on our members, and then designing the members, meaning sizing them in order to pass the code checks. As far as the loads on the structure, we will have dead loads, live loads, snow loads, and of course the self-weight of the structure. And we're going to have 5 load combinations, including 4 for ultimate limit state and 1 for serviceability limit state. Without further ado, let me jump into the program and start the modeling process. As you can notice in the program, I have already created my grid lines in order to help me with the geometry of the building. In the X direction, I have 9 grid lines that represent the location of the columns of my structure. And then in the Y direction, we have 3 grid lines locating the locations of the supports, as well as the rest of the beams for the structure. As far as the elevations, I have 1 elevation at the ground level, I have 1 for the pedestal level, 1 for the mid-level beams, and finally 1 for the terrace level. I have also created another set of grid lines to help me with the modeling of the infill beams for my structure that I'm going to use later in my modeling process. Let me go back to my main grid system and go to the pedestal level to start the modeling of my columns. So now for that, I'm going to use the column tool on the left-hand side. And then the first thing I'm going to need to do is to define the length of my column, which is 10 meters on top of the pedestal. And then I'll need to define the material and section for my column. To start, I'm going to use a 14 by 14 section for my column, but I know this may change in the code check and design process. So what I'm going to do, I'm going to click at the base of the column to place my column. Now let's go ahead and define the beams at the main level structure. So I'm going to go to the terrace level. And then what I'm going to do next is use the beam tool to create the beam for my main beams. So I'm going to define a glulam beam here, and I'm going to use a initial section of 215 by 532, start from the base, and with the length that I need. So as you can notice, I probably want the beam to rest on the column, so I'm going to need to go ahead and adjust the offsets for my beam. So I'm going to select the beam, go to the offsets, and change it to a full span beam instead of clear so that it rests on the column. So in the next step, I'm going to need to define some of my cross beams here. So what I'm going to do now is I'm going to change the grid level to my terrace beam levels. Now, because I already have these lines defined, it should be easy for me to go ahead and define my beams. I'm going to use the same section and material for the beams, but as far as the end connectivity, I'm going to release the moments because these beams will not have any moment resisting connections at the ends. So what I'm going to do now is I'm going to use the start and end points on my grid line in order to define all of these infill beams. Now for the next step of my modeling, I can go ahead and select all of these members that I have defined already and make copies with the distance that I want to replicate the same bay 9 more times. So what I'm going to do now, I'm going to use the copy command. The spacing is 10 meters, and since I have 8 bays, I will need 7 more to be copied. The next thing I'm going to do here is to define the last set of beams and columns because I need to make one more copy, and that will form my structure now. Now, as you may notice, I have some of these members not at the same level of the terrace level. So what I'm going to do now, I'm going to select all of my cross beams while holding down the control key. So that I can go ahead and adjust the offsets. I'm going to create a manual offset now, and this time this is going to be below the level. So I missed one here. I'm going to do that one manually. And now the top level of all of my beams will be at the same height of the structure. Now for the next step, I'm going to go ahead and define my mid-level beams. I'm going to go back to my main grid system and to the mid-level beam. And now all I need to do is to use the beam tool again and create the beam that I want. Now I need 6 more. So I'm going to make 6 copies with 10 meter spacing. And this should take care of all of my mid-level beams as well. Let me go back to the pedestal level. Now for the next step, I can go ahead and define the boundary conditions or the supports of my structure. And I'm going to assign a pinned connection at the intersection of the beams to the wall. So I can go back to my selection tool. Let me change my projection to orthogonal. And I can look at my structure from the top. So this way it's easier to select all of the joints I'm interested in. So I can go ahead and select all those joints. I can zoom in to look at my joints as well. And now I can go ahead and assign a custom degree of freedom joint and fix in the translation directions. And I will leave the rotational degree of freedom released in this case. All right, so now that I have my structure defined, I can go ahead and define my load cases and combinations. Now I can go to the define menu and to the load cases dialog. I will start by defining the self weight of the structure. I'm going to name it as self weight. And then all I need to do for Steamber to automatically calculate the self weight is to define the self weight factor in the direction that I need. Now in the next step, I'm going to define a dead load without the self weights. I'm going to create a live load case as well. I'll also create a snow load case in the same method. Now I can go to my load combinations. The first load combination I need is my dead load and my self weight times 1.4. So I'm going to use my self weight load case and then the dead load case and set the factor to 1.4. The next load combination that I need to create consists of 3 load cases, and it's going to include self weight, dead load, and the live load. My dead loads will have a coefficient of 1.25, and the live load will have a coefficient of 1.5. I'll create the same load case, but with the snow load case this time. I'll create another one including 4 load cases. It's going to include both the live load and the snow load as well, with coefficients of 0.5 and 1.5. In addition, I'm going to create one additional load case for serviceability. It's going to include 4 load cases, and it's going to include all of my load cases, self-weight, dead, live, and snow, with coefficients equal to 1. Now I'll accept this change, and in the design input window, I can now see all of my load cases defined. I'm not going to run any checks for my load cases alone, but I'm going to run strength cases for 4 of my load combinations, and I'll also run serviceability checks for my last load combination. Now it's time to go ahead and apply the loads. My intention is to apply loads to the cross beams in the terrace platform. Now what I'm going to do is I'm going to use a area load panel to distribute my area loads to the underlying members. So what I'm going to do now is use this panel tool, make sure the type of the panel I'm using is area load only. I'm not going to apply any material to this panel because I won't need that. And then what I'm going to do next is to draw a panel that covers all of the cross beams. Now you may notice that the span direction of this panel is not in the direction that I need. What I can do now, I can go ahead and select this panel, go to the span property, and change it to the direction that I need, which in this case is in the Y direction in the global coordinate system. Now I can see that the spans are looking better now. Now I can go ahead and apply area loads. I'll start with the dead loads. We are going to apply this in the global direction and have it decomposed to members. And as far as the magnitude, I have a 1.9 kilopascal load as for my dead load. Next, I'm going to use the same tool to apply the live loads. And this time I'm going to use minus 2.4 kilopascals for the live load. And then I'll also have a 3 kilopascal load for my snow loads. Now, if I zoom in a little bit and go to the finite element view, I can notice that this area load tool is now automatically decomposing my area loads to the underlying members. Now, all I need to do next is to take the area load that I created and make copies and make sure that I copy the loads as well. So in the X direction again, I'm going to use 10-meter increments And since I have 8 bays in total, I will need 7 more copies of this area load panel. Now I can see that all of the underlying members will have distributed loads decomposed to them. So now we have everything that we need defined, and all we need to do is to go ahead and save our model and run analysis for our structure. So we can see on the left-hand side the solver output window, which will show us the status of the analysis, and it will let us know if there is any FYIs or warning messages or error messages that we should be aware of. Now I can go ahead and look at the deflection of my structure. I can see how my structure is impacted. I can go ahead and take a look at the deflections and the other member diagrams as well. For example, I can take a look at a certain load case or combination. I can see the deformations and everything, and I can also review the forces in my columns, beams, and other components in my model. So now we can go ahead and run a code check so that we make sure that the members in our model meet the capacities and the code check requirements as per the defined code check as well. So in this case, I'm using the Canadian Timber Design Manual for performing the code checks. And in the first glance, I can go ahead and see that some of my members are passing and some of my members are failing. And this is because I didn't pay much attention to the cross sections that I initially used. So if I'm interested in seeing any of the results in more details, I can go ahead and take a look in the Timber Code Checks window on the right-hand side. I can drill down by object or by load cases, but I can see which member is failing and which member has the highest utilization ratio. And I can drill down more into the results, and I can see all the details that are used to calculate the capacity of my members. And I can do the same thing for all of the other code checks as well to get more information about the details of my code checks as well. Obviously, my model is not perfect at this time, so I'll need to do some adjustments, and I'll need to design my members so that they pass the code check. So I can go ahead and start my design process now. And for that, I'm going to first create some design groups in my structure. And what that means is similar members will have similar design results after we use the design result in our model. So in this case, for example, I'd like to put the outer columns in one design group, the inner ones in one design groups, the cross beams in one, and all the other main beams in one design group. So I'm going to go to the Define menu and then open Design Groups. I'll create one design group for the outer columns. I'll set the type of the members to columns, and then set the material to the column material. And then I'll also assign a section list, which is basically the list of sections that I'm allowing for my columns. And start with a 14 by 14 section for my columns. Now I'm going to make another group. This time name it Inner Columns, which I'm going to use for the rest of the columns. I'm going to use the same type, material, and sections for those ones. Next, I'm going to create another one. This time I'm going to use it for the main beams. I'll set the member type to beam. It's going to be a glulam material, and then glulam beam sections for the section list. And then I'm going to assign an initial section to my members as well. So this time I'm going to use 265 by 532. All right, so I'm going to make another one for my mid-level beams. I'm going to use the same properties for it. I'm also going to create one for the cross beams. I'm going to accept these changes. Now I'll go ahead and assign these design groups to my members. So the outer columns, I'll use this one. For the inner columns, I'll assign the appropriate group. Then I'll look at my structure from the side view and use the mid-level beams group for my mid-level beams. Then I'm going to go ahead and select my main beams. And assign the right group to those. And then I'm going to look at my structure from the top and select all other cross beams and assign the corresponding design group to those as well, the cross beams. Now at this time, I'm ready to go ahead and run a code check first. In this process, I'll make sure that I have code check results before I can go ahead and run the design process. And now I can see that again, some of my members are failing, so I can go ahead and run the design timber members, run design. And now I can select which groups I want to run the design for. In this case, I'm going to run the design for all of my groups. What this will do, this will suggest larger sections for the members that are failing and probably a smaller section for those that are over-designed. So what I'm going to do now, I'm going to run the design process on my structure. And now in the spreadsheet window, I can see that there is a design result node available to me. And I have some suggested designs in my structure as well. Now I can see that for each design group, there is a current section, there is a design section which is actually suggested to me, and then I'm being presented with the current utilization as well as the design utilization for my design results. So for example, something that grabs my attention is that for the inner columns, we were originally using a 14 by 14 section, which was basically failing the check. But now I'm presented with a 16 by 16 section that's yielding to a very reasonable design utilization for me. So what I can do now, I can go ahead and run the design again. And this time I'm going to run the use design sections command. So in this case, I can select which groups I want to use the design sections for. And if I want, I can go ahead and override my design as well. So if I do that, I'm being presented with a list of sections that pass my code check. And now I can see that this design utilization is very borderline for me. So I'll probably want to go with a larger section that yields to a more reasonable design utilization. Now in this case, I'm going to go ahead and accept this. And the sections are now swapped with the design sections. Now I can go ahead and run my code check one more time to see how this design process affected my structure. So obviously, since the sections changed, we need to run the analysis again, which the program has done already for me. And then we also ran a code check, and now we have all the code check results available to us as well. Now, looking at the structure overall, we can see that my members are all passing with good utilization ratios. And if I want, I can go ahead and take a deeper look at my member results. And I can see that, for example, as far as shear is concerned, I have a demand of 255 kilonewtons with a capacity of 265, which is yielding to a 0.96 DCR, which is the demand to capacity ratio, which is a very good and reasonable DCR for our results. We can also go ahead and create a PDF report of our results as well. So for that, I'm going to go to File menu, Export to PDF. And what this will do for me, it will create a report of all the code checks performed in my structure and give me access to a PDF report with all the utilization ratios reported, as well as the equations from the design manual that relate to the checks that we performed. Okay, so now I have a report generated for me. Probably I can zoom out a little bit. You can have more information on the report cover page as well. But what I'm really interested in is the detailed results for my code checks as well. So this is organized by member for me. And then for each member, the section is reported, the material is reported, and then the governing code checks for the load cases and combinations are reported for me as well. And I can also see references to the equations that are used for each of the code checks as well. And this is reported for all of the members in my model. So far, we have gone ahead and designed our structure using timber columns and glulam beams. In the next step, we're going to use steel for the main beams of the structure and design those beams using steel material. Now, the first thing we need to do is to go ahead and define some steel members. And for that, I'll need to define some steel sections and section lists as well. So I'm going to go to the Define menu and then Section Lists. And now I'm going to go ahead and create a new steel section list, which I'm going to use for my steel beams. And then I'm going to go ahead and define some sections from my section library. So now I'm going to go ahead and select a number of these sections to include in my design. These are basically the sections that I'm considering for my design. I'm going to add them to my section list and hit OK to create this section list. So now all I need to do, I can select one of the members that I was using. And since I have already put these main beams into one design group, all I need to do is to go into the definition of this design group, change the material to steel, and then apply the steel section list that I just created and choose a section to start with. I'm going to choose a relatively small section and click apply. Now I can see that all of my main beams are now having a steel material and are now assigned a steel section as well. Now, just like what I did for the timber design, I can go ahead and run my code check to get a preliminary check of this material as well. I'm having a clean solution. I can see that in the solver output window. And now I can see the results of the code checks for my steel members as well. So I can notice that the end main beams are having smaller utilization ratios, and the other ones are having a bit of a higher DCR, but all of them are failing at this point. So, and if I'm interested in seeing the details of my results, I can go ahead and look into my members in more details. And it's going to tell me why they are failing and what's the utilization ratio for the failing check. Now, again, just like what I did for the timber members, I can go ahead and run the design, but this time for steel members. And I'm going to run the design. I only had one design group for steel sections. And now I can go ahead and hit run. And it will consider all of the design sections in my design, in my section list, and it is suggesting one section. We started with W250 by 58, but it's now requiring a larger section, and it's suggesting W310 by 107 to me. My original utilization ratio was 2.63, and now the design utilization is 0.86, which is more desirable than what I had. Now I'm going to go to the Run menu and the Design menu again. And this time I'm going to use the design sections for this design group that I just studied. So now I'm going to click apply, and it's going to swap the sections of my steel beams with the design section. Now I can go ahead and run my code check one more time to see what's the resulting DCRs or utilization ratios for my steel beams this time. Now, if I go to my steel code checks and look at my highest utilization ratio, I can see that my inner main beams are passing with a code check utilization ratio of 0.86, and the other ones are having a smaller DCR, but all of them are passing now. In the next part, I'm going to take some time to introduce scripting capabilities that are available in Steamber as well. And that's delivered using a Python platform in the application itself. So you can use this Python engine to automate tasks or subtasks, which will enable faster design cycles. You can also use it to find your optimized design and make decisions faster. It can also be used to customize certain things. You can literally build your own feature using this capability, and you can adjust your workflows to suit the custom applications you're working on. And most importantly, once you have a customized workflow, you can deploy it across the organization to your colleagues or others you want this customization to be deployed to. Now, I want to use the same model that I was using before and apply this automation to it and see how I can benefit from it in action. So let's review the dimensions of this structure again. So the height, the length, and the width are the parameters that I'm going to use in my scripting in order to parametrically create this model. Okay, so I'm going back to Steamber now. And I can go to the script editor window. And here I have already written a script that can create this structure for me from scratch. So if I look at this script here, I have some variables defined, including the height of the terrace. This is the 10.5 meter height that we had before. The height of the mid-level beams, the width of the terrace, which is 80 meters, the number of bays involved, the cantilever length of the terrace, and number of infill beams in each bay. I also have the option to define my loads here and change the magnitudes if I wanted to. So for example, if I wanted to design this structure for a different region, I can go ahead and adjust my loads right away. Now, all I need to do is go ahead and run this script. And what this script is doing for me now is it's creating the model from scratch with all the parameters that I defined in my model. Now I can see that all of my structure elements are defined properly. I have all my loading as well. For example, if I look at my dead loads, they are being distributed to my members. And this model is now ready for me to go ahead and run a code check on. And once I do this, it's going to run the code check and analyze it for me. We can even use the scripting functionality to run the analysis automatically, run the code checking automatically, and perform the design performance as well. So now I see that I have my structure code check in a matter of seconds. And now if I want to change anything, I can go back. I can change the height, the mid-level height, or even some other parameters in my structure. So for example, if I want to use 10 bays instead of 8, I can easily do that. And this time the structure will be created for me with 10 bays instead of 8. So in this case, I have the structure created automatically for me with all the specifications that I had prepared, and I can go ahead and run the code check in a much faster way. All right, thank you for being with us in this session today. We're going to open the floor for some questions and answers now. Until next time.